The quadratic formula can be very useful when we're attempting to solve a quadratic because, like completing the square, it can be used on any quadratic regardless of what kind of solution we would get. Real, imaginary, complex, rational, all of those roots can be found with a quadratic formula just like they can be found with completing the square. I have a couple of songs to help us familiarize ourselves with the quadratic formula and where it comes from and what form our equation has to be in order to use it. So this is the information that will come from the songs. The first song is a more popular tune, which is why I use it, and it just gives us the formula. It's actually the way that I learned this formula back when I was in high school. The second song gives me not only the formula, but it also gives me this part that the equation has to be in order to use the formula. So the first song is to the tune Row, Row, Row Your Boat. X equals negative b plus or minus the radical b squared minus 4ac all over 2a. Yay! And the second one that tells us this extra part here is to the tune of Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula comes from the equation ax squared plus bx plus c equals 0. I mean, what would math class be without the terrible singing of your teacher? It's what you come to these videos for. I just know it. Now, the quadratic formula actually has a special piece in it that can give us more information about the kinds of solutions that we'll get when we do completely solve it before we solve it. And that special piece kind of gives it an advantage over some of the other solving methods. It's called the discriminant, and it's the part that I have outlined in orange there. Underneath the radical, the b squared minus 4ac. And finding just that portion can tell us if there are two roots or one root. It can tell me if those roots are real or imaginary / complex. And it can also tell me if they are real. It can tell me, are they rational or are they irrational? So let's find out, how does that discriminant actually help us? You may want to pause the video to write this information down. But when the discriminant is positive, that tells me that there are going to be two real roots, because when we have a positive number underneath the radical, that means that I will not have I to deal with coming outside of the radical. So I'll have two real roots. Now, positive numbers can be split up into two categories. We have perfect squares and we have numbers that are not perfect squares. If you have a positive number for your discriminant and it's a perfect square, then it is a indicator that we have two real rational roots, because that square root will take the perfect square and give you some sort of a rational number. Now, if the discriminant is not a perfect square, then you're going to have two real irrational roots, and that's because the number underneath that radical still has to stay underneath the radical. It doesn't come out as a nice, pretty, rational number. It's considered irrational. If your discriminant happens to be 0, then you will have one real rational root, and that's because the plus or minus won't matter, because you'll have plus or minus 0, which doesn't change anything when you add or subtract. If it is a negative root, a negative discriminant, then that indicates that you're going to have two imaginary or two complex, those can be used interchangeably, in this class at least, roots. And that's because you have a negative underneath the radical. We learned back a couple of sections that when you have a negative underneath the radical, it means that there are imaginary numbers. A list might be the best way for you to remember this information, but some people learn a little bit differently and learn better when it's more visual to them. So I've created this flow chart below to help us describe whether the discriminant tells me that it's a real root, an imaginary root, if it's rational or irrational. And here's how it works. Let's take the discriminant of 32 as an example. The sign of the discriminant is positive. It's not 0. It's not a perfect square. This means that my solutions will be two real irrational solutions. If we took the number 36, it's positive. It's not 0. It is a perfect square, which means we'll have two real rational roots. Either way you want to remember it, whether it's using this chart or using it as a list, you need to know how to use the discriminant. Let's jump into some problems where we use the discriminant and where we actually use the quadratic formula to solve. The directions ask us to find the value of the discriminant and then describe the number of roots and show our prediction was correct by actually solving the problem all the way out. The first thing that we're going to do is check to make sure that everything equals 0, and it does. So we'll label A, B, and C. I do ask that you label them outside and not just put arrows to them, because that indicates to me that you know to pull the correct sign, and it indicates that you know that the X doesn't come with the A, B, and C. So in this case, A is 3, B is 8, and C is 2. The discriminant can be found underneath the radical. I'll go ahead and plug in this to the whole equation to show you what it would look like. So we have negative b plus or minus the square root of b squared minus 4 times a times c. And all of that will be over 2 times our a. Oops, a is 3. Now, one of the things that I wanted to make sure I brought to your attention was that whenever you're squaring a number, it's always a good idea to toss it in parentheses. It's a must-have when it's a negative number. But if you just get in the habit of always putting it in parentheses, you won't have to remember when it's appropriate and when it's not appropriate. So this part that's underneath this radical is the part that's going to tell me what kind of roots they are. So I'll take the 8 squared minus 4 times 3 times 2, and I'm just going to toss that into my calculator. 8 squared minus 4 times 3 times 2, and I get 40. So my discriminant is equal to 40. That means that if you're using the flow chart, you would say that it's positive, it's not 0, and it's not a perfect square. So we would have two real irrational roots. To solve this so that we can show that our prediction was correct, we're going to replace what's underneath the radical with the 40 that we found. No need to do it more than once. And 2 times 3 is 6. So this negative 8 plus or minus the square root of 40 over 6, I need to simplify this 40 using a factor tree. 4 and 10. 2 and 2, 2 and 5. And whenever you're doing a factor tree, you're looking for pairs. Here, let me make that a little bit bigger for you. So we have 2 and 2. That's a pair that can come out side of the radical, and the 2 and 5 don't have pairs, so they stay inside of the radical. Notice that when they come outside of the radical, they go in between the plus or minus and the square root symbol. And 2 and 5 are 10. So once you've simplified your radical, it's time to see if you can reduce. And when you're reducing, you are checking the numbers that are outside of your radical. So the 8, the 2, and the 6. Those are the numbers that are able to be reduced. The 10 is protected inside of the radical, so it cannot change. So 8, 2, and 6, those are going to change and be divided by 2 to become 4 plus or minus 1 square root of 10, and you don't have to write the 1, over 3. This is my final answer. Number 2, let's label A, B, and C. A is 2, B is negative 6, C is 9. A is 2, B is negative 6, C is 9. So we will go ahead and plug this into our quadratic formula. X equals negative B, which means this is now positive 6, plus or minus the square root of B squared minus 4AC all over 2A, all over 2 times A, which is also 2. So we're going to type our discriminant into our calculator. Parentheses, negative 6, close parentheses, squared, minus 4 times 2 times 9. So our discriminant is negative 36. That means, negative 6 means that if we follow this flow chart, the sign of our discriminant was negative, which means that we're going to have 2 complex roots. Now we'll take and plug that negative 36 for our discriminant underneath the radical. So we have x equals 6 plus or minus the square root of negative 36 all over 2 times 2, which is 4. Remember from a couple of videos before that when we have a negative on our radical, it comes out as I. And the square root of 36, we can find that it's just 6. So 6 and I are both now out of the radical. And always check again to see, can they be reduced? 6, 6, and 4 can all be divided by 2. So we get 3 plus or minus 3I over 2. Number 3. A equals negative 16, B is 8, C is negative 1. We'll plug it into our formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So we'll type in our discriminant, the 8 squared minus 4 times negative 16 times negative 1 into our calculator. And when we do, we get 0. That means, following along on this chart, the sign of the discriminant is positive. It is 0, which means we're going to have 1 real rational root. So we'll have x equals negative 8 plus or minus the square root. Our discriminant was 0 over 2 times negative 16, which was negative 32. Now the square root of 0 is just 0. So all I'm left with is x equals negative 8 over negative 32. And that can reduce to be 1/4. Let's do a few more examples where we don't try to make the prediction from the discriminant. We're solely going to solve. As a result, these may or may not be solved for 0. So that means that we might have to do a little bit of maneuvering around before we can pull out A, B, and C. Prime example would be like number 4. We need to subtract 22x from both sides. And then we have ax squared plus bx plus c. So I can label a as 12, b as negative 22, and c is 6. Plug it into the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Be very careful because your b is negative. Typing your discriminant into your calculator. Be careful to put parentheses around the negative 22. And we get 196. So x equals 22 plus or minus the square root of 196 all over 2 times 12, which is 24. The square root of 196 is 14. So we have x equals 22 plus or minus 14 all over 24. Now you'll notice in this example I don't have I don't have any square roots, so we actually do need to solve this out. We'll have two separate equations to solve out. One will be 22 plus 14 over 24, and one will be 22 minus 14 over 24. So 22 plus 14 over 24 gives us 3 over 2. So remember, we want the fraction. And then 22 minus 14 over 24 gives us 1/3. Now, these problems that you would have exact answers, like this, where they're rational, those are the only ones that you are able to actually use the program that you have on your calculator for. Anything that is an irrational solution or an imaginary/complex solution, you are not allowed to use your calculator for them. Number 5, we'll subtract 9 from both sides. So A equals 1, B equals 12, C equals negative 9. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. type in that b squared minus 4ac into your calculator, that discriminant, and you get that x is equal to negative 12 plus or minus the square root of 108 is our discriminant over 2. 108 is not a perfect square, so that means you're going to need to do a factor tree over to the side for it. And if you don't know big numbers that go into the number that you're trying to do a factor tree for, using whatever smaller number you know is perfectly acceptable. So 2 and 54, that works too. And then you can break down 54 by 9 and 6. 9 is 3 and 3. And 6 is 2 and 3. And we're looking for pairs. So I have a pair of 2's and I have a pair of 3's. So x equals negative 12 plus or minus 2 times 3, which is 6, all over 2. Time to reduce. The negative 12, the 6, and the 2 are the only things that we're going to look at to see if they can reduce, and they can all be divided by 2. So x will equal negative 6 plus or minus 3 square roots of 3. For number 6, we'll subtract 13x from both sides. And then we can label our a is 10, b is negative 13, c is negative 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I can sing faster than I can write. So we'll type this negative 13 squared in parentheses in our calculator. Minus 4 times 10 times negative 3. And we get 289. All over 2 times 10, which is 20. Now, 289 is a perfect square. The square root of it is 17. So we have 13 plus or minus 17 over 20. This means that I'm going to need to actually simplify all the way to rational answers. So I'll have 13 plus 17 over 20. And I'll have 13 minus 17 over 20. So 13 plus 17 over 20 gives me 3 halves. And then 13 minus 17 over 20 gives me negative 1/5. I really recommend that as I'm typing these into my calculator, you are practicing typing them into your calculator to make sure that you get the same thing that I do. If you're not getting the same thing that I do, make sure that you ask about it. It would be a shame for you to get all the way to the quiz or to the test and realize that what you were doing wrong all along was calculator error, and you were doing the math completely correct. Number 6 again. Number 7. So we have to subtract 4 from both sides. 9x squared plus 6x minus 4 equals 0. A would be 9, B would be 6, C would be -4. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So again, we're going to type our discriminant into our calculator. 6 squared minus 4 times 9 times -4. And that gives me 180. (180) is not a perfect square, so we're going to attempt to use a factor tree. 90 and 2, 30 and 3, 6 and 5, 2 and 3. We're looking for pairs, pair of 2s, pair of 3s. So x equals -6 plus or minus 2 times 3. And inside the radical, I have just a 5. All over 18. And the 6 and the 6 and the 18 can all be divided by 6. So my final answer, we'll write it over on this side, will be -1 plus or minus the square root of 5 over 3. Let's take a look at a word problem. An amusement park ride takes riders to the top of a tower and drops them at speeds reaching 80 feet per second, a function that is modeled here when h is the height in feet, t is the time in seconds. About how many seconds does it take for the riders to drop from 60 feet to 0 feet? This word about is my green light to get a decimal. So let's label A, B, and C. A, B, and C. -16, -64, and 60. And if we think about this for a second, the time that it takes for the riders to drop from 60 feet, the highest feet that it goes, to 0 feet. So from here down to here, here's our 0 feet. That right there is an x-intercept. So we're looking for the solution, the roots, the x-intercept, the solution. That will give us the time, because t is our time and that's on the x-axis, and h is our height. So I'll use the quadratic formula for it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So in your calculator, you're going to do -64 squared minus 4 times -16 times 60. And you get this big number. For the discriminant. But remember, we got a green light that allowed us to be able to round. So we don't care that that big number isn't a perfect square. We're not doing a factor tree for it because we're not looking for an exact answer. We are allowed to type into our calculator 64 plus the square root of this number divided by -32. and 64 minus the square root of this number divided by negative 32. And when we do that, give me a second to type it in. When we do that, we get one of our solutions at negative 4.78 and one of our solutions at 0.78. Now, negative 4.78 doesn't really make sense when we're talking about how many seconds does it take for something to happen. It can't take negative seconds. So the one that we want to include is this 0.78 seconds.